All right, lesson 10.3. We are still multiplying our polynomials, but these are special products. So these are just shortcuts if you don't want to have to FOIL like we learned in 10.2. Remember, you're multiplying everything in one by everything in the other, okay? So that will always work, right? But in 10.3, they're just showing us some special products, okay? So shortcuts that they fall into these patterns we can use instead of having to multiply everything in one by everything in the other, okay? Eventually, we're going to look at going in the reverse. So factoring is what it's called, but these will help with that too. But just if you recognize this special pattern, then it makes your multiplication a little quicker instead of foiling, okay? So our special product patterns are called a sum and difference pattern, or something called the square of a binomial. Okay, and the sum and difference pattern, these are both working for multiplying two binomials, okay? So remember, binomial means two terms. So the sum and difference just means if I have the product and it's the same two terms, but I'm adding them and then multiplying by their difference, right? It's a sum and a difference. These are the same and these are the same. Then instead of having to multiply everything here by everything here, we can just say that's going to equal this first one squared minus the second one squared. Okay? So, for example, right, if you have 2x plus 3 times 2x minus 3, right? This is 2x and this is 3, okay? It's just plus here and minus here. I'm going to write that as 2x squared minus 3 squared. And then when you square that, you would get 4x squared minus 9 instead of multiplying everything out. Okay? Just shortcuts, right? Not that you can't FOIL, but should make it a little simpler for you. Okay? A little quicker. All right. Square of a binomial. Squaring just means raising it to the second power. So what this means is if I have a binomial, so two terms, and I'm squaring it. So either a plus b, or you could do a minus b to the second power. Okay? Remember what it means to square something. So what this is actually saying to you is it's a plus b times a plus b. Okay? So again, instead of multiplying that out, I can write it as the first term squared plus 2 times the product of the first and the second plus the second squared. Okay? Same with a minus b, it's going to be the same pattern, except this sign will be different. It'll be the first one squared minus 2 times the first times the second plus the second squared. Okay, same pattern, but if it's minus here, it's minus here. Okay, so what that's meaning is we'll use this 2x plus 3 again. So I have 2x plus 3 raised to the second power. Instead of multiplying it out, I can write it as the first one squared, so 2x squared. It's plus, so this is plus 2 times the first, so 2x, times the second, plus the last squared. Okay, so then 2x squared is 4x squared, plus 2 times 2x is 4x, times 3 is, what's wrong in your notes, by the way? So looking here, that would be 2 blurry, but this 2x plus 3 in your notes is wrong. it should be 2 times 2x, which is 4x, times 3, so it should be 12x plus 9. Yeah, did that wrong. Okay, so just shortcuts for multiplying special products of your binomials. All right, so let's just do a couple examples to see how we can apply them. All right, so we want to find the product of 3b minus 5 times 3b plus 5. Okay, so again, looking at it, they look similar. They're only different by a plus and a minus. So we're going to say this is like a minus b times a plus b. Okay, so it falls into the sum and difference pattern. So I'm going to do this first one squared minus the second one squared. So 3b squared is 9b squared minus 5 squared is 25. And I've multiplied my two binomials. Okay? Then if we do 7a plus 2 squared, quantity squared, right? So again, it's one binomial. We're raising it to the second power. So it falls into that square of a binomial pattern. So that means we're going to take the first one and square it. Then we're going to add 2 times the first one times the second plus the second one squared. All of these, the sign is already taken into consideration with the product. So I'm really just worried about the number and the variable, okay? I don't need to worry about the plus or minus, it's already there. Then we just simplify. So 7a squared is 49a squared. 2 times 7a is 14a, times 2 is 28a, plus 2 squared is 4. So I just squared that binomial using my special product. All right, then to see it with subtraction, right? It's going to work the same way. So 2p minus 5q quantity squared, right? It's a binomial raised to the second power. So I'm going to take the first one and square it, 2p to the second power. It's subtraction, so I'm going to put subtraction here. Then 2 times the first times the second. Remember, I don't worry about the sign because it's already taken in right here. Plus the second squared. Okay, so 5q squared. You square the whole term, not just part of it. Then simplify. So 2p squared would be 4p squared. Negative 2 times 2p is negative 4p. Times 5q is negative 20pq. Plus 5q squared is 25q squared. And that's the product of our of 2p minus 5q squared. Okay? All right, this is also useful for mental math. I know we have calculators, I know you're allowed to use them, but sometimes we don't want to have to use a calculator. Maybe our calculator is broken, maybe we lost it, okay? So we can use this for mental math, right? So consider a product like 19 times 21. Well, I could write it out, but that still requires a little more time, okay? So I notice that 19 and 21, I can get them both by rewriting. 19 is just 20 minus 1. These are numbers that are easy to work with, right? 20 and 1. And 21 is 20 plus 1. So this is 19 times 21, right? Just written differently. But now it's one of our special patterns. It's a sum and a difference. They're the same numbers, just being added and subtracted. Okay? So then I'm going to say it's a special pattern, sum or difference pattern, that ends up being the first one squared minus the second one squared. 20 squared is just 400. 1 squared is 1. 400 minus 1 is 399. So I was able to do that in my head without having to pull out my calculator, without having to use long multiplication. Okay, I was able to do it in my head. Then if I have a number squared, same thing, right? 38 squared in my head, well, that's going to be 38 times 38, okay? But we can rewrite 38 as the difference of two easier numbers, right? 38 is just 40 minus 20. These are numbers I can work with in my head. So we're going to say it's 40 minus 20 squared. Well, that's a square of a binomial. So it says I take the first one and I square it. It's subtraction, so it's minus 2 times the first times the second plus the second squared. So 40 squared, right? 4 squared is 16. Then we're squaring, so we're going to add 2 zeros. 2 times 40 is 80. Times 2 is 160, so minus 160 plus 4. So this ends up being 1440 plus 4, which is 1,444. All in our head without having to use a calculator. Okay, so again, these are just useful for us. They're not required, right? I could still multiply these all out if I wanted to. Same with the binomials, but it gives us a shortcut so we don't have to FOIL everything out. Okay?